Okay, so the title of this lesson is Expressions and Equations. Expressions and equations with radicals and rational exponents. And this is from section 8, topic 1. Can somebody get that? Section 8, topic 1. Need your homework too, please. All right, example 1. We are taking the fourth root of 324 m to the 12th times the cubed root of 64k to the 9th. Now we've worked a little bit with like fourth roots, cubed roots, fifth roots, stuff like that, but not a whole lot. We have done a lot of work with square roots, okay? This little number is called the index, and that tells you how many factors you're looking for. When there's no number there, it's the square root, okay? So like, what's the square root of 64? 8, because 8 times 8 is 64. You have two of the same factors, right? What's the square root of 16? 4, because 4 times 4 is 16. You have two of the same factors. When there's a 4 there, I'm looking for 4 identical factors. So if we did 2 times 2 times 2 times 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. What's the fourth root of 16? 2. The square root of 16 is 4. The fourth root of 16 is 2. It's 2 times 2 times 2 times 2 is 16. Okay? If I'm looking for the cubed root, I need 3 of the same factors. So like 3 times 3 times 3 is 27. Is 27 a perfect square? No, we can take the square root. It's going to be a decimal, right? But what's the cubed root of 27? 3. So that index is what that number is called. It tells you how many factors that you need, how many identical factors you need. Same sign, same number. Coolio? Now, our calculators, the exponent is a 9. Yeah, 64k to the 9. We know on our calculators how to find the square root. But if it's a fourth root or the cubed root or the fifth root, you don't use the radical sign. That's just for square root, all right? If you have a graphing calculator on your desk, I want you to follow along with me so that you're familiar with how to do this. Now, 324, it may have a perfect fourth root, it may not. If you're looking for a root higher than 3, you have to put the root in first, okay? So we're looking for the fourth root. So what you would do is you would hit 4, and then math. Look where my finger is. It's on the math key. Boom. This menu pops up. If you look at option 5 right here, see how the index, there's an X there? That's whatever index that we chose. We chose 4. You got to put it in first. So if you want cubed root, option 4 automatically has the cubed root, so you don't have to hit 3 first. If you do hit 3 first, that's okay. You can just use option 5. Okay? But we're using option 5. So you can scroll down to it, or you can just hit 5. And that's the way it looks. It looks weird. It looks like 4 times the xth root of something, but it means the 4th root. If you have an updated TI-84, yours probably actually looks like it does on our paper, but if not, this is what it's going to look like. Okay, so then just put 324. Is 324 have a perfect 4th root? No. Darn. So we're going to have to use a factor tree. That's how I do it. So I'm going to make myself a little workspace over here. We've done factor trees in here before. What I want to do is I want to break 324 down to all of its prime factors and see if it has a perfect 4th root in it. Like a factor that's perfect. So a lot of kids get confused. They're like, I don't know how you know what numbers to start with. Well, you can start with different factors than I do as long as the numbers you're choosing are actually factors, okay? I don't know the factors of 324 right off the top of my head, but I know that this is an even number, and if it's even, it has to have a factor of 2. So that's where I start. And so I just take my calculator and I say 324 divided by 2 is 162. So that means 162 times 2 would give me 324. Are either of those numbers prime? What? What did you say? Yes or no?
Yes.
What's prime mean? Prime means that the only factors of the number are 1 in itself. So does 2 have any factors besides 1 times 2? So 2 is prime. Is 162 prime? Nope. I know it's even, so I know it's got to be divisible by 2. 81. Again, 2's prime. I always underline my prime numbers because I'm going to need to go back and find them at the end, and so it just helps me if I underline them. 81 is not divisible by 2. Well, it is, but it doesn't divide evenly. But we know that 9 times 9 is 81. Is 9 prime? No. Give me some factors.
3.
3 times 3. Is 3 prime?
Yes.
Yeah. And both of those 9s break down to 3 times 3. So everything's broken down to all prime numbers. So I'll write those in order. I have 2 times 2 times 3 times 3 times 3 times 3. So 2 times 2 times 3 times 3 times 3 times 3 should give me 324. And it does. So you're like, well, why do we go through all that? Well, I'm looking for a number that has a perfect 4th root. So I need 4 identical factors. Does 324 have 4 identical factors?
Yeah.
Yes. So if we multiply all those together, the result will have a perfect 4th root, okay? So that would be 3 to the 4th power is 81. And anything that you have left, just multiply it together, okay? Somebody get that, please. So instead of writing 324, I'm going to rewrite it as 81 times 4. Do you have your homework?
Yeah.
Do you have your homework?
I think so.
And then I'll go back and take the 4th root in a minute. Now, m to the 12th. When you have an exponent, a variable with an exponent, you're not taking the 4th root of 12, you're taking the 4th root of m to the 12th. Now, I'm going to show you why it is what it is, and you don't have to do this every time, but sometimes it helps to visualize it. Doesn't m to the 12th mean m 12 times? M times m times m times m times m times m. 12 times is m to the 12th. Do I have 4 of the same factors? Yeah, I got it a couple times, right? So there's a group of 4. There's a group of 4. And there's a group of 4. How many groups of 4 do I have? 3. So when I say what's the 4th root of m to the 12th, what do you think it is? M cubed. It's how many groups did I make of 4, okay? Here's the easy way to do it. Take your exponent, divide by the index. What's 12 divided by 4? Boom. That tells you how many groups of 4 that you have, all right? So I'm just going to leave it as m to the 12th right now because it's a perfect 4th root. I'll come back and take care of the cubed root of 64k to the 9th in a minute. Let me just simplify this. Okay, so I've got it rewritten. What is the 4th root of 81? Go back over to your math. How did we get 81? It's 3. If I wasn't sure, take my calculator, although we should be sure because we know that we did 3 times 3 times 3 times 3 to get 81, right? But if I wasn't sure, put your root in first, hit math, option 5. We want to know the 4th root of 81, 3. So if I take the 4th root, I put that number on the outside, okay? So I have taken care of 81. Does 4 have a perfect 4th root? No. Some kids say 1, because 1 times 1 times 1 times 1. What is 1 times 1 times 1 times 1? 1, not 4, okay? 4 breaks down to 2 times 2. I've got 2, it's perfect square, but it's not a perfect 4th root. So since I can't take the 4th root of 4, 4 would stay under the radical. And what did we say the 4th root of m to the 12th is? M cubed. Boom. There's no m's to stay under the radical because it had a perfect 4th root. Coolio? So we're still multiplying, we haven't forgotten, we're multiplying by the cubed root of 64k to the 9th. So we know 64 is a perfect square, but we're not looking for perfect squares, we're looking for perfect cubes. So I will check in my calculator, or I could do a factor tree if I wanted to. If I'm looking for cubed root, you don't have to hit the root first, you can just go to math. Option 4 is just for cubed root. And I'm looking for the cubed root of 64 is 4. So 4 times 4 times 4 is 64. Yay, we don't have to do a factor tree. Is k to the 9th a perfect cube? 9's not a perfect cube, it's a perfect square. But is it k to the 9th a perfect cube? If I wrote k out 9 times, how many groups of 3 would I have? 3. And also, 9 divided by 3 is 3, right? So we don't have to break any of this down. We can just go ahead and take the cubed root. So the cubed root of 64 was what? 4. And the cubed root of k to the 9th is k cubed. Do I have anything left to go under the radical? No. And I'm just going to bring this down here so it's... Okay, now listen here. When you multiply radicals together, the radicand, which that's what's under the radical sign, you can only multiply those together if you had the same index. We didn't have the same index. We had an index of 4 and an index of 3. So from the beginning, we couldn't multiply the radicands together. Otherwise, we could have done that if we wanted to, or we could have simplified them separately like we did. But because they don't have the same index, you can't do that, okay? You can always multiply the coefficients. That's what's outside of the radical. You can multiply those together, and it doesn't have to have the same index, all right? Because they're not under a radical. We didn't have, only coefficients we had were 1. Right now, 3m cubed is not under the radical, and 4k cubed is not under a radical. So we can multiply those together, and we get, what's 3 times 4? 12. M cubed times k cubed. Do they have like bases? No, so m cubed times k cubed is just m cubed k cubed. My first term has a radical, the second one doesn't. So the second one doesn't have anything under the radical to multiply by, and it wouldn't have the same index anyway. So we just have to bring down times the fourth root of 4. Can anything else be simplified? Nope. That's my answer. Now, when you're doing these on your own, they're not going to take that long to do because I'm over explaining everything because I know this can be kind of confusing. And we're making a video, so if you go back and watch it later, I want you to, have a good, thorough explanation. Yes? So right here, I'm multiplying these two together. And since 3m cubed is not under a radical and 4k cubed is not under a radical, I can multiply them together. So 3 times 4 is 12. M cubed and k cubed, they don't have the same base. So I can't keep the base and add the exponents like you normally do when you have exponents. So I just write m cubed times k cubed and then bring down the radical. Okay? Everybody cool with that? Example 2 won't take us nearly as long, but example 3 will. Example 2. That is EX, although it looks like something crazy. The fourth root of 625 k to the 12th y to the 8th. The fourth root of 625 k to the 12th, y to the 8th. X. Did I say k?
Yeah.
Sorry. X to the 12th, y to the 8th. So 625, I don't know if it's a perfect fourth root. I'm either going to do a factor tree, but before I do that, I'm just going to check in my calculator. So we hit 4, math, option 5, 625, enter. Yay, there's no decimal, so 5 is the perfect fourth root. All right, let me check my variables first to see if I need to rewrite them. Can I take the fourth root of x to the 12th? Yeah, what would it be?
X3.
X cubed. Can I take the fourth root of y to the 8th? Yeah, what would it be?
Y2.
Y squared. So I don't have to do a factor tree or anything. So I'll just write, what was the fourth root of 625? What's the fourth root of x to the 12th?
X3.
X cubed. And the fourth root of y to the 8th is y squared. Is there anything left to go under the radical?
No.
Nope. That's it. So they're not all going to take forever. And on this one, I wasn't multiplying by anything or adding anything or anything like that, dividing. So that's all I had to do, just simplify the radical. Cool beans? Example 3, yeah. All right, I have 6 times, and this radical I'm going to make on 2 lines because it's a fraction. The cubed root, the numerator is 1,250 u to the 7th v squared divided by the quantity of 128 u to the 10th v to the negative 4. What is this? Okay. So before I start taking the cubed root, I'm going to see if I can simplify any part of this fraction. Okay, I'm not taking the cubed root. I'm just going to see if I can simplify. If I can divide 1,250 and 128 evenly, I would go ahead and do that. 1,250 divided by 128. It doesn't divide evenly, so not going to worry about that. I could reduce it if I wanted to because they're both even, so I know they're both reduced by 2, but I'm not going to worry about it. What I am going to worry about is I have like bases in the numerator and the denominator. Okay, so I'm going to put them both in one place, either both in the numerator or both in the denominator. And then I'll worry about taking the cubed root after I get all that finished. Okay? Now what you can do, this radical is written as one giant radical. To me, sometimes it's less confusing to write it as the 6 times the cubed root of 1,250 u to the 7th v squared in the numerator. And then in the denominator, write another radical. Now the 6 only goes in the numerator. It doesn't go in the numerator and denominator. Okay? And the denominator, write the cubed root of 128 u to the 10th v to the negative 4th. And I'm going to do that, but I'm going to wait till I have it simplified first. Okay? So, u to the 7th divided by u to the 10th. Anybody know what that is? Okay. I visualize it. I say, okay, u to the 7th means u times u times u, 3, 4, 5, 6, 7. Divided by u to the 10th is u 10 times. Put another u over here. So we know u divided by u is 1, u divided by u is 1, u divided by u is 1, and on and on and on. 3. And where are they, the numerator or the denominator? They're the denominator. So u cubed will go in the denominator. Now the rule says if you are dividing like bases, as we are, the rule says keep the base, and you put it in the numerator. Subtract the exponents. You always take the exponent of the numerator minus the exponent of the denominator. Okay? Now that's going to give us u to the negative 3 in the numerator. But we have it, we said it's supposed to be in the denominator, right? And positive. Well, do y'all remember, have we worked with negative exponents? A little bit. You don't want a negative exponent. Only if you're doing scientific notation do you want a negative exponent. So the rule says if you have a negative exponent, to get rid of it, just change the location of the base. If it's currently in the numerator, if you move it to the denominator, it changes the sign of the exponent. Not the coefficient, but the exponent. Bless you. And so in this case, if we could just put a 1 up there, if we were just solving this problem right here. If it's positive, if we had u cubed and we moved it to the numerator, it would become negative. So to change the sign, you just have to change the location of the base. If it's in the numerator, put it in the denominator. If it's in the denominator, put it in the numerator. All right? That is the way it is. In my head, I go, all right, where do I have more u's, in the top or the bottom? In the bottom. How many more do I have in the bottom and the top? 3. So I know I got a u cubed in the bottom. Okay? So we'll rewrite that with u cubed in the bottom, no u's in the top. Now v squared divided by v to the negative 4th. The rule says keep the base and subtract the the exponents. So I would have 2 minus a negative 4, which is what? V to the 6th. You could do it like that, or you could say, okay, well, when I have a negative exponent, I can't keep it negative, so I have to move it. Is v squared negative? No, so you don't want to move it to the denominator or you'll change it to a negative, so you leave it in the numerator. V to the negative 4th, we don't want that negative exponent, so if it's in the denominator, we'll move it to the numerator. We already have v's there, so when you multiply and you have like bases, the rule says keep the base and do what to the exponents? Add them. So 2 plus 4 is 6. Either way, we get the same thing. So when we simplify this, I'm going to rewrite it. I'll put u cubed in the denominator, and we'll simplify this to v to the 6th in the numerator. Coolio? Okay. And I'm going to rewrite it like 6 times the cubed root. I'm going to write my radicals separately. 1,250 v to the 6th divided by the cubed root of 128 u cubed. I haven't taken the cube. You don't have to rewrite it like this. You could still leave it with one giant radical. But to me, it's less confusing if you make it two separate ones. And treat them separately, okay? Is everybody cool so far? Okay, I knew you were. Just check it. So hopefully 1,250 will be a perfect cube. I'm gonna check my calculator. So math, option 4, 1,250. Nope, not today. So that's all right. We'll do a little factor tree. Now 1,250, it's even, so I could divide by 2. Or if there's a bigger factor that you want to use, we could do that too. Isn't? I could do 5, I could do 50, I could do 10. I think I could do 250. Yeah, 250 times 5 is 1,250. You have lots of options. Just because I started there doesn't mean you're going to start there. No matter where you start, our prime factors are going to be the same. Okay? So is 5 prime? Yeah. Underline it. Is 250 prime? No. I could do 25 times 10, right? Neither of those are prime. 10 breaks down to 2 times 5, and 2 and 5 are prime. 25's factors are 5 and 5, and both of those are prime. So I'm going to write all my prime factors. 2 times 5 times 5 times 5 times 5. I need groups of 3. What's 5 times 5 times 5? 125. And then whatever's left, just multiply it together. So 10 times 125 should give me 1,250. And it does. If it doesn't, then something's wrong. You forgot a prime factor or you broke something down incorrectly. Okay? It does. So here, I'll replace 1,250 with 10 times 125. Is v to the 6th a perfect cube? Can I take the cubed root of v to the 6th? Yeah. 6 is not a perfect cube because its factors are 3 times 2 or 6 times 1, okay? But it's not 6, it's v to the 6th. What's the cubed root of v to the 6th? V squared. So we'll come back to that, right? All right. Let's see what we can do with the denominator. So the cubed root of, I'll check in my calculator to see if 128 is a cubed root.
No.
It's not? Darn. Okay, well, so we'll have to do another factor tree. No problem. I know 128 is even, so I know it is divisible by 2. And 2 times 64 is 128. 64 is also divisible by 2, but I know it's also 8 times 8, so I'll use that because I'll break it down quicker. Is 8 prime? No. What are factors of 8 besides 8 and 1? 2 and 4, and both of those we got to break down to 2 and 4. 2's prime. Is 4 prime? Nope. Factors of 4 besides 4 and 1. 2 and 2. So I have 1, 2, 3, 4, 5, 6, 7 2's. Just double check. 2 to the 7th power is 128. And I'm looking for your groups of 3 of the same factors. I've got 2 groups of 3. So 2 times 2 times 2 is 8. 2 times 2 times 2 is 8, and then times 2. If I multiply a perfect cube times a perfect cube, the result's going to give me a perfect cube as well, okay? So instead of confusing us, we can go ahead and multiply 8's together because they were both perfect cubes. And didn't we say earlier that 64 was a perfect cube? Yeah. What's the cubed root of 64? 4. What's the square root of 64? 8. Different numbers. They're both perfect. One's perfect square, one's perfect cube. So I will rewrite 128 as 64 times 2. U cubed. Can I take the cubed root of that? Yeah. Now I haven't actually taken the cubed root of anything yet. Okay, this 6 that's on the outside, it's the coefficient of the radical. Anything I take out of the numerator, I will multiply it by the 6 that's already there. Okay, so I'm just going to rewrite it. 6 times, what did we say the cube root of 125 was? 5. So it'll be 6 times 5. Can I take the cube root of 10? Nope, so 10 stays under the radical. What's the cube root of v to the 6th?
B squared.
V squared. And I can come back and simplify that in a minute. Like multiply the 6 and 5 together. Over, what was the cube root of 64? 4. Can I take the cube root of 2? No. I mean, I can, but it's a decimal, and so if it's a decimal, it just stays under the house, under the radical. What's the cube root of u cubed?
1. It'll just be u.
So just u, 4u. So we've taken the cube root, but we can simplify this. In the numerator, 6 times 5 is, 6 times 5 times v squared would be 30v squared. Over, or I'm sorry, times the cubed root of 10. In the denominator, we just have 4u times the cubed root of 2. We're almost finished. I promise the rest of them won't take this long. Or will they? They won't. So our coefficients are the numbers that are outside of the radical. Can I reduce 30 and 4? Is there a number that goes into 30 and 4 evenly?
Yes. 2.
2. Is that the largest number that goes into 2 and 4?
Yes.
Yeah, okay. So 2 goes into 30 how many times? 15. 2 goes into 4 how many times?
2.
2. All right, v square and u, are those like bases?
No.
No, so we can't keep the base and subtract the exponent, right? Now, what's under the radical can be simplified with what's under the radical here as long as they have the same index, and they do. Because remember, this is the same thing as if we had 10 divided by 2, all under one giant radical. And can we do 10 divided by 2 evenly?
Yes.
Yeah, and would that go in the numerator or the denominator? Numerator. So 2 goes into 2 once, 2 goes into 10 5 times. So the cubed root of 1 is 1, so that kind of goes away. So I know this is confusing. I'm not going to give you one this crazy on a test, but I want you to have seen it in case you run across it on ACT, SAT, something like that. So in the numerator we have 15 v squared times the cubed root of 5 divided by 2u. And I don't need to put the cubed root of 1 because the cubed root of 1 is 1. Because 1 times 1 times 1 is 1. And that is your final answer. Anybody have any questions? Comments or concerns? All right, page 155. Example 4, 15g raised to the x squared minus 3x plus 5. That is only g's exponent, not 15's exponent. 15's exponent is 1. If there is parentheses around the 15 and the g, then it would be the exponent of both, but it's not, okay? Divided by the quantity of 45g raised to the negative x plus 8. So negative x plus 8 is only g's exponent, not 45's. If there was parentheses around 45g, then it would belong to both of them. But 45's exponent is just the 1. Now, I know this looks crazy, but it's really no big deal. NBD. Okay? We don't have any radicals here, so we're just simplifying a fraction. 15 and 45. If that was just by themselves as a fraction, could we reduce 15 and 45? Yeah, what goes into 15 and 45 evenly? What? 15. 15 goes into 15 once. 15 goes into 45 3 times. 5 also goes into both of them evenly, but you would still be able to reduce if you just divided by 5, right? What do we have next? We have a g in the numerator and a g in the denominator. So the rule says when you have like bases that have exponents, keep the base, subtract the exponents. We can do that, okay? So let's bring 1/3 down. When I keep the base and subtract the exponent, that's going to go in the numerator. So keep the base of g, always the exponent of the numerator, minus the exponent of the denominator. Since I've got 2 terms in the denominator, I'm going to want to use parentheses because I'm going to need to distribute that negative. If you don't use parentheses, you're only going to end up subtracting the negative x and not distributing it to the positive 8, and that's going to change your whole answer. Coolio? So let me do this. Do I need this 1 here? No. So I'll just write g raised to the x squared minus 3x plus 5. Distribute the negative. What's negative times negative x? Plus x minus 8. All over 3. Can I do any simplifying in that exponent? Any like terms? Yeah. Negative 3x and positive x combine, and positive 5 and negative 8. So I'm going to simplify combine like terms. So I'd have g raised to the x squared has no like terms. What's negative 3x plus x? Negative 2x. Positive 5, negative 8? Negative 3. All over 3. And that's it. I don't have to factor the exponent, nothing like that. I'm just simplifying it as far as I can go. It didn't say factor the exponent. We just have to remember our exponent rules. When you're dividing like bases, keep the base, subtract the exponent. When you're multiplying like bases, keep the base and add the exponent. The next one, okay, listen. Y'all are going to go, is this a joke? It's really not as bad as it looks. All right, so just bear with me. Example 5. We are taking the 5th root of negative 3,125 a to the 15th, b to the 4th, c to the 9th, times the cubed root of 392, a to the 4th, b to the 5th, c cubed. Very funny one, don't you think? I know. If I wanted to multiply the radicands together, remember radicand is what's under the radical. In this example, could I? If I wanted to multiply the radicands together, radicands what's under the radical, could I? I hear a yes, I hear a no. Why do you say yes?
All the exponents have identical bases.
All right. They do. If there weren't radicals, I could totally multiply them together. The reason I can't multiply these together, I'm telling you, you can't. Anybody know why? Which is called the index. If this was the 5th root and this was the 5th root, I could totally multiply them together and leave it all under the radical, okay? But if I have the 5th root here and the cubed root here, I can't do it, all right? So I'm gonna have to simplify them separately, and then we'll see what happens after I simplify to see if there's anything I can multiply together, like the coefficients, okay? If I have anything left under the radical, I still won't be able to multiply it together because my indexes are not the same. Does that make sense? All right, so I'm just gonna simplify them separately. Now, can I take the 5th root of a negative number? I can't take the square root of a negative number. Well, I can, but what is the square root of negative 4? Well, what's negative 2 times negative 2?
Oh, 2.
Positive 4, right? What's 2 times 2?
4.
Positive 4. So we can't do it in the real number system. What's the square root of negative 4? 2i. 2i, right? Remember imaginary numbers? But that square root, the index is 2, okay? When the index is an even number, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, y'all know the even numbers. When it's even, if you take the root of a negative, you're going to get an imaginary number. Is the same true if it's odd? Check this out. What if I said, what's the cubed root of negative 8? Well, what's the cubed root of positive 8? 2. 2 times 2 times 2 is 8. Can you do the cubed root of negative 8? What's negative 2 times negative 2 times negative 2?
Negative 8.
Negative 8. So is it possible to take the cubed root of a negative 8? Yeah. It's negative 2. Negative 2 times negative 2 times negative 2 is negative 8. If your index is odd, you're not going to get an imaginary number, okay? Because you can do that. It's odd. You can take the cubed root of a negative. If it's even, a negative times a negative is a positive. A positive times a positive is a positive. It's going to be imaginary. All right? Okay. So let's hope that we can take the 5th root of negative 3,125. So since it's 5th root, we put the root in first. So 5, math, option 5, negative 3,125. Boom. So negative 5 times negative 5 times negative 5 times negative 5 times negative 5 is negative 3,125. All right. So I'm going to rewrite this, and I'm going to write everything in perfect 5th roots, which this is already. Will we be able to take the 5th root of a to the 15th? Yep. Okay, so I don't need to rewrite that. I mean, I'm going to write it again. B to the 4th, can I take the 5th root of b to the 4th?
No,
Why?
because it doesn't have a 5 for it.
I don't have enough b's. Yeah, I have b times b times b times b. I have 4 of the same factors, but I need 5 of the same factors, right? So I'm just going to write it, nothing I can do. How about c to the 9th?
It has one.
It does. If we rewrote that as factors, like we can do, right? When we have numbers, we rewrite it as two factors, that one of them is a perfect whatever root we're looking for. So would you agree that c to the 9th is the same thing as c to the 5th times c to the 4th?
Yes.
Right? Keep the base out of the exponents. So I can take the 5th root of c to the 5th, and then c to the 4th doesn't have enough c's, so it would just stay under the radical. So you can do that with variables just like you do with their coefficients, okay? Let me just go ahead and simplify this one over here too. 392. I don't know if it's a perfect cube, but I can do a factor tree or I can check my calculator. So math, option 4, 392. Not a perfect cube. So I'll do a factor tree on that. I know it's divisible by 2 because it's even, and 392 divided by 2 is 196, so 196 times 2 are factors. 2 is prime. 196 is also even, so I know it's divisible by 2, and 2 times 98 would be the factors. 98 is also divisible by 2. 49 times 2 gives me 98. And then factors of 49, I've got 7 and 7, and 7's prime. So my factors, my prime factors are 2 times 2 times 2 times 7 times 7. And I'm looking for groups of 3 this time. So I've got 3 2's, so that's going to make a perfect cube. 2 times 2 times 2 is 8. Whatever's left, just multiply those together. So I'll replace 392 with 8 times 49. Okay? Everybody cool with that? Is 8 to the 4th a perfect cube?
Yeah. It has one cube.
It has a perfect cube in it, right? So how can we rewrite 8 to the 4th so that it's a perfect cube? A cubed times A. If you weren't sure, write A to the 4th as A times A times A times A. You're looking for groups of 3. So that would make A cubed times A. B to the 5th. We know B to the 5th isn't perfect, but does it have perfect cube factor in it?
Yes.
Well, how would I write it?
B3 times B2.
B cubed times B squared. Running out of room. Is C cubed a perfect cube?
Yes.
Oh, good, because I'm out of space. C cubed. Anybody have a question before I go and simplify? No? Okay. What was the 5th root of negative 3,125? We did it in our calculator. Negative 5. What's the 5th root of A to the 15th?
A3.
A cubed. 15 divided by 5. Can we take the 5th root of B to the 4th?
No.
No, so B to the 4th will stay under the radical. What's the 5th root of C to the 5th?
C.
Just C. Can we take the 5th root of C to the 4th?
No.
Nope, so C to the 4th will stay under the radical. Am I going too fast? Too slow? Or just right? Yes, sir.
With those exponents out there, do you have like when it's like b to the fifth, do you have to split it into b cubed and b squared?
If you're doing it on your paper and you know, like, okay, I'm going to put a b on the outside and leave a b squared under the radical, you don't have to, as long as you can do that all in your head and get it correct. You know what I mean? Okay. All right, now we're multiplying times whatever we have over here. What's the cube root of 8? 2. It goes outside the radical. If you take the root, it goes outside. Can we take the cube root of 4? I'm sorry, 49. No, it's perfect square. It's not a perfect cube. So 49 stays under the radical. What's the cubed root of a cubed? A. What about just plain old a? Cubed root of a stays under the radical. What's the cubed root of b cubed? B. How about the cubed root of b squared? Nope, so b squared stays under the radical. What's the cubed root of c cubed? C. Boom. Can we multiply our radicands together? No, we can't. Remember, radicand is what's under the radical. They still have different indices. I think it's the plural for index. Y'all tell me. But the coefficients, those are the numbers outside the radical. I can multiply those together regardless of what's under the radical or whatever the index is. That doesn't matter because they're not under the radical anymore. So I'll multiply these together. So negative 5 times 2 is negative 10. I've got an a cubed times a is a to the 4th. I've got a b over here and not a b here, and I'm writing it alphabetically, so just a b. And what is c times c? C squared. And my radicals, I'll just write separately because I cannot multiply those together. And that's all we can do. I have one more example. And remember I told you don't have homework over this. Does anybody have a question on this problem? Anyone? Anyone? All right, page 156. Example 6. 24m, and m is raised to the 4/3 x minus 5 divided by the quantity of 16m, and m is raised to the 8/9 x minus 6/5. We don't have radicals. We have a fraction we got to simplify, right? Can I reduce 24/16? What goes into 24 and 16? Greatest number? 4. Is there a one larger? 8. 8 goes into 24. 3 and 8 goes into 16 twice. Now look, when we have m's, we have like bases and we're dividing. So the rule says keep the base and subtract the exponent. So I'm going to rewrite this. 3 in my numerator, 2 in my denominator. When I keep the base in the numerator. Take the exponent of the numerator, subtract the exponent of the denominator, and since there's two terms, we're going to have to use parentheses so that we distribute. Bless you. Alright, so I have in the numerator 3m raised to the 4/3 x minus 5. Distributing the negative, I get minus 8/9 x plus 6/5 all over 2. Okay, do I have any like terms I can combine in that exponent? 4/3 x and -8/9 x I can combine, right? And then -5 and +6/5. Of course, we have fractions. We're not turning them into decimals. Don't even think about it. We're going to add and subtract fractions. So 4/3 x and -8/9 x. I'm not going to worry about the x for now because all I got to do is add or subtract the coefficient, right? So I'll do that on the side. I have 4/3 minus 8/9. Now remember, when you're adding and subtracting fractions, you have to get a common denominator. And what's it going to be? 9. Y'all remember how to add and subtract fractions? Good, because we learned it in 3rd grade. Or I learned it in 3rd grade. I don't know when y'all learn it these days. In my bottom fraction, if my denominator doesn't change, then my numerator doesn't change. Okay? To be equivalent, it can't change if the bottom didn't, the denominator. For 4/3, the new denominator is 9. So to get an equivalent fraction, 3 times what is 9? 3. So to be equivalent, I have to multiply the top, the numerator, by 3 to get 12. Now, just to make sure, what does 12/9 reduce to? 3/4? 4/3. Is that equivalent? Yeah. Okay. So 12 minus 8 is 4. Subtract the numerators. The denominator, you do not change. So 4/3 x minus 8/9 x will be 4/9 x, right? So let me write this over here. And I also have to combine -5 and +6/5. One's a fraction, one is not. Can I turn -5 into a fraction? What do? Put a 1 under it. So I have -5 over 1 plus 6/5. Obviously, I don't have a common denominator. So what would my LCD be? 5. The bottom fraction, 6/5, the denominator doesn't change, so the numerator won't change. And notice I'm just bringing the sign with it. But my top fraction, the denominator did change, so the numerator has to change if it's equivalent. 1 times what is 5? 5. So you have to multiply the numerator by the same thing. -5 times 5, -25. And now we can add and subtract the fraction. So if -25 plus 6 gives me over 5. So -5 plus 6/5 is -19/5. Is there anything else I could simplify, reduce, combine, divide, add, subtract? Nope, that's my answer. You have any questions?
What were you saying again? So just wanna write it down, if you're dividing into the base
When you divide, the rule says, like if I have x to the m divided by x to the n, I have like bases, right? So the rule says keep the base, subtract the exponents. And it's always the exponent of the numerator minus the exponent of the denominator. Anybody else have a question?